This is the Amp Hour Podcast. Released November 18th, 2018. Episode 416. An interview with James Bruton.
Welcome to the Amp Hour. I'm Dave Jones from the EEV blog.
And I'm Chris Gamble of Contextual Electronics.
And you've also got James Bruton from X Robots.
Welcome,
Hey, James.
How are you doing?
Thanks for joining us.
We are really tempting the fates here. We're going across two oceans, and we have James on one side and Dave on the other, and me stuck in the middle. So, welcome, and glad we all got here today. That's great.
Yep, thanks for having me.
And where are you from, based on the accent?
Yeah, in the south of England, so Hampshire, which is quite near the south coast, near the Isle of Wight, but about 20 miles north, roughly.
Right.
So you mentioned X Robots. What is that if people don't already know?
Well, so xrobots.co.uk is my website that I registered back in probably 2004 when I started building robots, and I put a video out today actually about my robotic history of the robots that I tried to build before YouTube even, and certainly before people had 3D printers. So that was really a bit of history there to try. I've basically tried to build walking robots that were human size, which obviously is quite hard, and couldn't find any easy tutorials about it, so I decided to have a go myself and write about it on a blog.
That's
And
awesome.
that's how it all started, really, at least in my adulthood.
What actually prompted that in the first place? I mean, something must have sparked the, all right, I want to see a walking robot that I've made.
Yeah, I guess I've been interested in making stuff since I was a child, and I've built various things, in the past. Studied electronic engineering, formerly at degree level. That was in the 90s, though. So, yeah, I don't know, really. I've worked in IT ever since, and always held an interest in engineering and that sort of thing. So I thought, why not? That'll be a challenge. I guess one of the things was to be better at writing software, which I'd done, a bit of C and a bit of Python and stuff, but never really had an application, so seemed like quite a good one. Why not start with something really hard?
Yeah.
Yes, you picked quite a hard one, I gotta say. I mean, that's
Well, here we are 14 years later, and I've almost achieved it.
right.
How hard was it back in 2004 or whatever it is, or even before that, when you first, compared to today? Because today it seems like, oh, okay, it's another walking robot. It's still,
Yeah.
I mean, engineers like us can understand how impressive it is, but it's kind of like, yeah.
Yeah, I can't
everyone's
even
doing it.
remember. Did Arduino exist then, or did it come along since then?
That was 2007, I think.
Was it?
No,
Yeah,
maybe
YouTube
later.
was.
A little bit cheaper, a little bit sooner, rather.
Yeah, so there were still PIC chips and other microcontrollers, but that's, I'd done Z80 once upon a time, but that was
Nice.
about it, my microcontroller knowledge. So, like the initial ones, I didn't even, I had, as I mentioned in the video that went out
Yeah,
today, I had
yes.
sort of like a serial servo controller I could control from VB6,
Yes.
and I had that turning I
love Visual Basic 6.
Yeah, well, I think lots of people loved it because it was really easy to access, like
Yeah.
the parallel port
Yeah.
and things like that. So yeah, I basically had those servos turning potentiometers to make analog voltages,
Oh,
and then
nice.
comparing that analog voltage with a feedback joint pot on the joint to give me, a difference with an op amp, and that switched to relay either way to make a sort of relay H bridge to make the motors work. So that was the initial way that it was all controlled. I mean, I probably could have done better even with a PIC or something, but, that was innovation.
That's great, man. I was noticing, so I watched that video, and it is a great history, and I really like that you kind of go through it. But the thing that struck me about it, when would you say this was the first one that worked? Like, that actually worked as you had hoped it to work?
None of them worked as I hoped they would, but, like, Android 2 did actually take steps and it could go along. And I can't find the video. I wish I had the video. 3 was pretty good, I suppose. But, you couldn't really... I don't know if... was eBay around then? I don't know if
Yeah,
there were
it
so
was.
many Chinese
Yeah,
sellers,
that's-
at least.
Oh,
even
yeah,
if
but
it was,
wasn't. It's not the same.
Yeah.
Exactly. Like, now you can go and buy anything you want, like lead screws, ball screws. Not to mention brushless motors and cheap gearhead motors. There just wasn't really that sort of quantity of stuff, not to mention companies like Adafruit with Arduino modules and libraries
Right.
that, let's just plug in a sensor and here's some code and here's the numbers in variables straight away,
Well, I think the thing I mean, like, it sounded like, it does sound like the the stuff that you had sent out, or sorry, the stuff that you were doing, it was working to a little bit of a degree, but at least from my watching of it, it almost sounded like 2014 was when that's when it started to click and really got there. And then I was thinking about that. I'm like, oh my God, you persisted for 10 years though. You kept doing it. And so what the hell made you keep going? Like that's amazing. What is this drive that you have around walking robots? That's what I was impressed by.
I'm not sure. I think as soon as I started another one, I'd have another idea of a way to do it better. And so that's something that kind of occupied my thoughts until I actually tried it. And then as soon as you start, I mean, I always say the favourite projects of mine are ones I haven't started yet.
Yeah.
I know
as
that
soon
goes,
as you start them, you go, oh, I wish I hadn't done it like this, or I wish I was doing something else, or, you're bored of it halfway through sort of thing. So, even with OpenDog, I've thought, oh, I shouldn't have done it like that. I should have had compliant joints and series elastic actuators.
Should have made a cat.
There you go. But then, I mean, that's, in a way, it represents traditional robotics in that it's very rigid and has a mathematical model. And I can always build another robot with springy legs, as a separate, maybe slightly smaller, cheaper project. But that's why there's so many robots. I'm looking at all of those robots right now, and there's a lot of them.
Have you often regret? No, probably regret isn't the right word, but you do like a build as you go videos kind of thing, right?
Yeah.
And you must get a ton of feedback. Do it this way. Do it this way. Do it this way. Try this. Try that. Do you get?
Oh yeah,
sick
absolutely.
Of that,
and
or
I mean,
is that?
Oh yeah. So even on what are we on OpenDog 13 or something
Right.
now? Even on part 12, there were people saying, "Oh, I knew it wouldn't work," and it was like I've just made done the first steps,
Right.
Sorry, it doesn't immediately work as well as Boston Dynamics.
So
That's a great comparison too. Yeah.
Would you
Really
do you
easy.
think that often? Oh, it's better if I just finish something and then post document it via videos or something like that. Oh, it's working. I'll go do a series of videos on it.
Potentially, although with something like OpenDog, I think it is really something that is going to last for years.
Right.
All the stuff they'll eventually do, hopefully. So it's not really feasible to store it all up
Yep.
and then have hundreds of videos.
Got it.
Plus, also, I need to earn some money from Patreon and
Right.
YouTube ad revenue. So I need to. I mean, it's quite time consuming. So doing a video every week, I've got to make some content ultimately. So there are other projects that go on in the background, like when I did the giant Lego electric skateboard, which was about 800 hours of printing.
Wow.
And I did all of that.
God.
Jeez.
And I had the thing made. Then I put the first video
Right.
out. So the next one after followed fairly quick after. Rather than it being, I've made 3 bricks this week, So that's more of a background
Right.
content, and I have foreground content, which is my regular week on week.
Yep. So do you do live stuff at all? Live show?
Patrons only, yeah, it's
Right.
a monthly, hour-long live stream.
Cool.
I don't think I want to do too much public because the videos end up really long and people aren't engaged with them so
Yeah,
much.
true.
So I don't know what that does to engagement.
Oh, right. The actual channel metric and that sort of stuff, and the magic algorithm, and yep. Right.
For people that haven't seen your channel yet, could you explain what OpenDog is?
Yeah, so OpenDog is a dog-shaped robot in that it's got 4 legs. It's not anatomically correct to a dog by any means. Its knees point the wrong way and stuff. But
doesn't even pee on
Yeah, it
things
doesn't
or
even lift its
whatever.
hind
No,
leg.
not
and,
yet.
Yeah.
it's about the size of the Boston Dynamics Spot Mini, but I think it's probably heavier. And it's chunkier looking. And it's made with 3D printing and CNC aluminium, and all its joints are brushless motors, which are from drones, some good Hobby King turning G1s, and basically ball screws, and it's got 12 joints, so each leg has a knee, a hip, and another axis at the hip, essentially, a shoulder, if you like. And it's got a kinematic model, so it calculates the inverse kinematics for all of the joints all at once. So it's got a 6-axis controller with 2 3-axis joysticks for 3 translation moves and roll, pitch, and yaw. And it can operate all of those simultaneously. And I did a couple of episodes on that mathematical model, which isn't quite as accurate as it should be, but it does work. And it's all running 8-bit Arduinos at the moment, which are due to get upgraded to Teensies, which are 32-bit and 180 megahertz instead of 16 megahertz.
That's the thing I find
2650.
interesting. You're talking about real time kinematics and control and everything, and Arduino in the same sentence. To me that doesn't compute.
Yeah.
No pun intended.
Yeah, I mean, I'm pushing it, and also there's lots of Arduinos all strung together on serial buses and stuff.
Right.
but that's
Right.
just, I mean, basically I'm going along with the O-Drive development, which at the time I started this doesn't support CAN bus. They have just got CAN bus in beta, so
Right.
then I can throw away all my 3 megas with lots of serial ports and go to 1 teensy with CAN bus straight down all the O-Drives. And there's 6 O-Drives which are dual brushless motor drivers.
Right. So do you have an Arduino controller for each motor and then a central one controlling, or is it...
No, the O-Drive has got its own PID controllers and it does the encoder handling.
Right.
So they've got the brushless motors, each one's got an encoder coupled to it, which have got 8,192 counts per revolution, which makes it more accurate than a stepper motor and more powerful, and of course being they're 2 kilowatt brushless motors. They're current limited at the moment to about 30 amps on 24 volts, but I could push them if I wanted, if I could get batteries that would source enough current for all 12.
Right.
So the O-Drive does all that encoder handling.
Got it.
And does the positioning. It will do end stop calibration and all that stuff. So you can literally just send the positions and motor speeds to the O-Drives,
and it'll
it just
take care
handles
of
it
it.
for
Okay,
you.
well that's why you're able to do it with the Arduino controller. Otherwise, you'd stand no hope, right?
Oh, absolutely. You'd never count the encoders
Yeah,
at
yeah, of course.
3,000 RPM. It would be ridiculous. So I believe the O-Drive's running STM32s. So yeah,
3,000 RPM is really fast
yeah.
to me. Is that why? Can you tell us why you have to run it at such a high speed, and then presumably torquing it down? Sorry, I'm not a mechanical.
Also, no, I'm not, but
you
that's
know.
the capability of the motor.
Right. Okay.
But yeah, so I'm using ball screws. So they're roughly a 2.14 to 1 belt ratio to a 1605 ball screw. It's still pretty agile, even with the current limiting and the motors on 24 volts instead of 48. I think it's enough to be as agile as it needs to be.
I'm a little confused right now. You have to excuse me. So yeah, I've never done anything with motors.
Yeah,
actually.
same here. I'm not a motor guy.
And so
okay.
that's why I'm super excited to talk to you about this stuff. But like, I've heard reverse kinematics over on Embedded FM. I know Alicia talks about that a lot, and I've heard that from robot friends I have, not friends who are robots, but people who work at robot companies. Could you explain what that is, and specifically to how much of it you need to understand as the robot maker?
So which part, the inverse kinematics?
Yeah, let's start.
Yeah, I mean,
there.
like, are you doing math equations, or is it like you're implementing libraries?
No, I did all. Well, you could. There are various ways of things integrated in ROS and over other open source platforms, which will do it for you, where you put in the dimensions and it's solved. I did it as an educational series, so there's 2 videos about it. Each one is solving 3 of the axis. Oh, sorry. Well, the first one is solving translation, and the next video is solving the rotation axis. So there's 3 axes in each video, and I did that by basically drawing triangles all over the side view and so on of the dog, and doing the trigonometry.
cool.
Oh, right.
And so all the Arduino code is loads of arctans and
Okay, so
everything,
you
but
measure the robot, take the physical dimensions and angles, and program that into your system.
yes.
Right.
So the kinematic
awesome.
model is basically
Yeah.
saying, so you put your hand on your cup on the table, you can work out, what your joint angles are, your shoulder, your elbow, your wrist maybe, and therefore you can work out in Cartesian coordinates in X, Y, and Z in straight lines where your hand is.
Nice.
So inverse kinematic is saying, well, I want to go to that cup on the table, that I know where the X, Y, Z is. Now what is the solution for all of my joints? And there could be more than one solution, because you could, theoretically
circuitous
invert your
paths and-
elbow
Yeah,
or
right.
turn your arm upside down.
How do you decide? Do you leave it up to it to decide which solution to choose, or do you?
So in this case, there's only one solution, because the elbows, if you like, or the knees, whichever way you look at it, I think they're elbows because they bend that way, but they don't turn inside out, fortunately. So, and I can't do a complete 360 of any of the joints. So there's only one solution, and my triangles never turn. They never get 2 sides flat, which breaks the maths. So actually, the straight trigonometry worked out, and then just doing arctans or whatever the inverse function is to get the, to work it all back essentially. But most of this stuff was, what we have GCSEs in England, which is your secondary education. Most of that's GCSE maths. And I really wanted people to be able to understand, what I was talking about. If they've got like one GCSE and a piece of string and a protractor, they can understand it. And so there's all these diagrams. It's literally me drawing with black marker over a printout of the CAD of the side of the robot, saying, right, here's the hypotenuse, the opposite adjacent, we know this angle, now we need to solve this angle.
SOHCAHTOA. That's all I'll ever
all of
remember.
that. So, but essentially, I still had to go on sort of the mathsisfun.com website for high school kids to try and remember how, or like some of it's
Join the
Pythag
club.
as well.
I don't remember anything I learned.
Yeah,
It's
exactly.
like, you know.
Well, I think that's important though too, is to point out that like, okay, yes, there's going to be math here. Yes, it's important to actually understand it. That's what I think you're saying, right? Is that understanding the math underneath is important for troubleshooting and translation and everything else in the software, but that. Yeah, you don't need to have it. You don't need to be a math genius to, you don't have to be like an innate math genius. You need to be able to look at resources and then go and stick with it and do it. Is that accurate?
Yeah, that's how I did it.
Yeah.
Yeah,
That's
so
great.
I probably could have, I don't know, I probably still would have had to have pulled out a textbook probably.
Right.
Or at least look up how to solve Pythag again. But yeah, I mean, essentially
Yeah,
it's the
right.
application of the stuff you learnt at school that you've never used since, depending on what your job is.
Right, and doesn't it piss you off that like this is like they should friggin' start with a robot? If I saw a robot first, and then they're like, "This is why you need to know SOHCAHTOA," it's like, "Oh, okay." Like, look at that robot. I want to do that. That's so friggin' cool. Like.
Yeah, there is that. And so I do. I haven't done any recently, but I have done a couple of school visits where I have gone in with like BB-8 or something like that when at the time Star Wars was out. And even to talk about kids who are programming in Scratch.
Yep.
And like teach them something like there's quite a lot of stuff in Scratch, like functions, like abs, the absolute function, which is like really simple and really useful, and no one knows it's there. And that's something that I use, like for a motor driver or something to turn the negatives positive to drive the PWM positive, but out of separate pins. And that's how BB-8 works, and then they can relate to what that function does.
That's awesome.
Does it always have to be? Is it always this? Easy in quote marks math, or is it like when you get to the Boston Dynamics level, do they implement like yet another layer of PhD math on top of?
I don't know because they haven't published their source, but I'd imagine it's slightly more complicated. And in fact, I'm as far as I know, those robots are compliant and they're like force forward kinematics. So I believe on a crude level, what happens is
what's force forward?
Yeah, so I believe what they do, and I don't know this is fact, but what I believe is that they have compliant joints. So they have their actuator or whatever, and then there's a springy bit in the middle, and then it's attached to the joint, and that springy bit is measured. So if I were to do that, I'd have to run so fast to get the measurement of the springy bit back into the mathematical model. So it'd be like constantly trying to catch up. So I believe what they do is they just smash the legs into the ground, measure the distance, and then use forward kinematics to work out where the foot is, and now they know.
Right, so they have like the spring joint modelled. Well, they've physically measured all the properties of that spring joint, and then that goes into their kinematics model.
I think it's measured in real time, but basically instead of trying to work out inverse kinematics, they approximately move the legs where they want. And then when they comply with whatever with the ground, when they just smash that foot into the ground, then they know all the joint angles then because the legs hit its destination.
Got it.
So then they can roughly work out what the pose of the body is. And then you can do inverse kinematics to operate the weird head arm on top to keep the gripper still.
Right, yep.
Because then you know the pose of the body. So that's approximately. So I want to do another robot, or at least build one leg on a jig that jumps up and down.
Right.
That basically pulls up a springy tendon and then has a foot sensor, and when it hits the ground, it either complies or it unwinds the springy tendon. And then we can calculate the kinematic model from wherever the leg ends up, essentially.
Yeah, I guess so. Like when I think about like robotics, I always think down at like the motor control level, but it sounds like that stuff's not figured out. But it's
easy.
It's abstracted away at least, right? Yeah.
Yeah. I think that's the. I mean, the motor driver part isn't too hard, but so for OpenDog, the brushless motors and the O drives are kind of the most advanced motor drivers and the sort of top quality that I've used. Never used brushless before. And brushless motors, the power in them is bonkers these days. You think about these.
Right.
You think about what a 2 kilowatt brushed motor would look like, a DC brushed motor. It's a massive thing, and these are, relatively small for the power you get out of them, but being able to control them accurately and everything else. So I'm so glad that's taken care of with O-Drive.
And what is O-Drive?
So O-Drive is a dual brushless motor driver, which the encoder links to, and it handles all the encoder handling.
And it's an open source. It's an off-the-shelf open source.
It is totally open source hardware, yeah.
And
Right,
what
so the
sort of
yeah.
processor is that running?
I think it's STM32.
Right. Yep.
So to talk about abstraction again, so what you said you hand the O-drive controller a spin this fast, or you say go this many steps, or what do you actually when
you can
send
tell
a
it to
command
go to a
the O-drive
certain
controller?
position. It has positional
at
stuff.
a particular speed.
Okay, so you say do 30 revolutions and end at this angle or something.
Well, yeah,
like
we're
that?
being in encoder counts on the motor, so at 8,192 per revolution of the motor. Mm-hmm. And even on load, I've managed to get it down to plus minus 10 encoder counts, which is pretty accurate.
That's awesome. Yeah. Wow. So
Why is there plus minus 10? I need to know.
Oh, just approximately in terms of accuracy.
Yeah, but why they're encoder counts? Why can't you count to the plus minus 1? Why is there a plus minus 10 error there? Is it slipping the motor, the encoder, or?
I don't know. I mean, we'd have to look at how brushless motors are driven. So what are they? I don't know how many poles they've got, but I guess there's a certain accuracy you can be with the motor in terms of its how accurate it can be in one revolution.
Right.
With 8,192 clicks per revolution,
right,
that's still pretty accurate.
And does that change based on the load? Like the larger the load, you get more slip and...
That was on a test load with me with a test leg. I guess it would do, but that was the test load I did, which was the initial test leg of me holding the leg and trying to stop it. So,
right.
The encoder's also used to actually drive the brushless motor. So the brushless motor obviously has to have the right poles driven at the right time because it's brushless. So the encoder's used to sync up as well. So it does a calibration routine where it works out the motor stator position relative to the encoder, so it can actually drive it. And that's what's so special about brushless motor drivers, because they're three-phase essentially.
Which is why you wouldn't want to be rolling your own, right? You're better off just using an off-the-shelf platform like O-Drive, right? Because there's so much work.
Yeah, exactly. I mean, there are others around there, but this is the only one really that's meant for robotics that does the accurate encoder positioning.
So let's just talk about a single leg of the Open Dog.
Mm-hmm.
So one leg has how many drives on it?
Three motors. So one and a half O-drives.
Okay. And so that means that there's you said there's an elbow joint. I guess with a dog it's weird, but like an elbow joint, there's a hip joint.
Yeah, so I've got a knee or an elbow, whatever it is, in the middle of the leg.
Okay.
Then another joint at the top, which I guess we'll call the shoulder. I think I called them what did I call them? I must have called them elbow, shoulder, and hip. Weirdly. So essentially, the elbow's in the middle, the shoulder is at the top. So if you imagine your arm, it looks like that at the moment. And then if you wave your arm outwards, lift your arm out the side of you, that's the hip joint
right
on each one. So
right, and that gives you kind of like how wide the stance is, right?
That's it. So,
yeah. Okay. Interesting. And what made you choose that configuration in the first place?
I looked at the Boston Dynamics robots, and it looks a bit like what they do, but I think they might have another one up at the hip or shoulder that allows the leg to rotate, because I don't have that.
I've got to ask, what do you... Like, everyone's seen the Boston Dynamics videos, right? That's what everyone raves about. They go viral because they look so just...
Creepy. They're so creepy.
Yeah, so creepy. Creepy's the word. And do you... Like, tell me if you think the same way. When I look at... Everyone looks at that and goes, wow, look at how advanced these things are. And I go... Like, because it's doing some trick, right? It's doing some jump up boxes or doing whatever it's doing. The engineer in me says, no, they've spent 3 months solid programming it to do that one trick. It can't do anything else. You know, like it's not like just automatically doing that. Oh, here's throw random objects in front of it and it does all sorts of it just does the business like a human.
No, I guess that's the thing with was it Atlas doing the backwards flip or whatever?
Yeah.
I mean. Yeah, I don't know. You don't know how many times it fails, whether that's like 1 in 100 though as well.
Until they release the blooper video, which is our favorite thing here.
Yeah, so the Boston Dynamics dog doing the dance thing they released recently, there's even a jump cut or 2 in that video. There's at least 1, which means it didn't do it consistently all the way through enough for them to make the film. So, you don't know.
So how far do you...
The truth must come out.
How far do you think they're away from like a robot that can do... like human, like random stuff. Like you just put it in a random room and it can do things.
Like reactive
right? Yeah,
type things,
I
Dave?
think we're still a long way from that.
Well, it depends
long,
whether
long
what
way.
you expect it to do. I mean, in terms of its physical presence and its physical ability, it's pretty good, I suppose. But whether it's got good enough sensors to work out, you know,
Right.
how to get out of the crystal maze or whatever,
Right.
I don't know. Do you have that? Does everyone know what I'm talking about? It's
Might as
possibly
well
just a
explain it.
UK TV
Yeah.
series where it's
Yeah,
like
right.
contestants who everyone shouts at because they're never clever enough have to go into like escape rooms essentially and solve a puzzle
Yeah.
or
Right. Okay. Yep.
do something, you know.
Yeah.
Nice. Nice.
No, I'm just talking about interacting with people in a room or something. Like
Oh, okay.
if it could it go up and detect people and randomly shake their hands and say hello, and like
Well, that's
something
definitely
basic
possible.
like that.
I guess it is, but I don't know really. I don't know what goes on inside Boston Dynamics, but there are robots that'll do that. Sure, there's lots of human interactive robots.
Would you take a job
Right.
there or elsewhere if offered?
I don't know if they'd offer me a job, to be
Oh,
honest.
right. Okay.
But then I'd have to give up YouTube.
Right. Yeah. Right.
Yeah, they probably wouldn't let you show it before the final
No.
video, huh?
Well, there'd probably be no
Yeah.
time. I mean, I'm doing YouTube almost full time now, so
Yep.
yeah,
Yeah.
effectively, I do another 16-hour-a-week day job for doing some design work for a startup, working from home. But rest of the
Jesus.
time I do YouTube, so you know,
Wow.
it's that's something I want to do. So I don't know if I would. I've turned down other jobs doing things people wouldn't normally turn down.
Who are the major players in this space at the moment?
What, robotics?
Yes. In the sort of stuff like the humanoid kind of, Boston Dynamics kind of robots. I mean, surely they're not the only players.
Well, I don't know. So there was obviously Honda and Asimo.
Asimo, I've seen Asimo.
believe-
It was pretty.
Has Asimo
poor.
been retired now or something?
I think
I'm not
so
sure.
because when I saw it,
He
at
danced
like,
his hips off,
and
probably.
it fell down steps, and it just it was good for the time. It was groundbreaking, but now it's like kind of like just funny to watch,
Yeah, so Toyota did some stuff as well.
right?
I mean, none of them are really. They're not. I mean, I guess these are R&D projects
Yeah.
Yeah.
rather than. So Boston Dynamics are going to be selling Spot Minis. That's, I guess, the
Oh,
first
really?
company who've
Oh, I
actually
didn't
made
know
a.
that.
Yeah,
Right.
the first company who've actually said, "Well, this is our product now."
Oh, okay.
Whereas you
Yeah,
could
they're
never
actually,
buy
they're
an
actually hiring
Asimo.
like crazy for that right now, if people don't know. So if you want to go build robots, Boston Dynamics will hire you, apparently.
right.
Right.
It's crazy.
Oh, okay.
Yeah.
And I assume they're based in Boston.
Yep.
Yep. Okay, just a guess.
Didn't they come out of MIT or something?
I forget where the guy started, the founder started
Wasn't it
from,
all to
but
do with the MIT Leg Lab?
maybe, yeah. I don't know.
Yeah,
So
so I don't
Honda,
know. I
Toyota,
mean, I
Boston
guess in terms of
Dynamics.
actual robotics companies, there are a number of robotics startups that Google acquired. But they did have Boston Dynamics at one point, didn't they? But they've sold it. So
They did.
Oh, did they?
Yeah.
Oh, I
believe
didn't
so.
know they.
Yeah, that was Andy Rubin, the guy that started Android and has been in the news for
Oh, right.
not great things lately. He basically was bought by Google. Android was bought by Google, and then he went on a buying spree at Google and bought a bunch of robot companies, and then he left.
Yeah, right.
It's like, okay. So, yeah. What's it called? Rethink just closed, though, too. So that was a robotics company, right?
Right.
They were an assistive robotics company. Rethink Robotics did, like, the Baxter robot. So they just closed. They just shut their doors.
Well, it's not surprising. Ultimately, you've got to have you've got to make money, right? This is a business.
Yeah.
I mean, there's not many organizations that can just sink, I don't know how many tens of millions they put into, this
Well,
sort of
SoftBank
R&D.
saves the day again.
yeah, so I guess
Who
we
owns
should. I
Boston
guess we're
Dynamics?
honourable mention to Onki or Anki, who obviously I did a paid review recently for Vector, but they've done quite well. So they've had a lot of VC funding, and they also, I think, their Vector, Kickstarter did about $1.8 million or something.
But that's only going to last so long, though.
Yeah, sure. But I mean, the basic roadmap there is to make robots that interact with people better. So, there's a lot of comments on the video that it doesn't do very much.
Right.
But, that's the first, one of the first steps on the roadmap. So
Uh-huh.
What is Enki?
it's, Anki's a company. They made Cosmo, the little robot with the scoop thing that picks up the blocks.
Oh, okay.
And now
Yeah, I
Vector,
saw-
which looks
I
very
saw that.
similar, but it's instead of being sort of smartphone driven, it's you talk to it and you can just not have the phone. And it's
That
very
was like
interactive.
a robotic pet type thing, though,
Yeah, it
wasn't it?
recognises your face and it'll, it's almost a home assistant.
Yeah. I
So
saw
they-
there
yeah.
was I think a Wall Street Journal article about like personalized robots and how they're just kind of more cutesy than they are functional. And it's like, well, why are they there? And the answer is because people buy them.
Yeah, I mean, that's the appeal. So people either love it or they hate it, I think, and a lot of people love it. But yeah, it is very interactive. It's like a pet and stuff. But it is small and you can put it in your pocket and take it around with you. So I believe...
Have you seen that Pleo, that robot dinosaur?
Yeah.
You know? Mm-hmm. What did you think of that? Because I thought that was really cool.
That's a few years ago. Yeah, I never actually seen one in real life.
Yeah, I've got like one that hasn't got its skin on. It's been skinned.
Oh, right.
And it's very cool.
Yeah, sure. I mean, that's... I mean, even some of the robot toy BB-8s and stuff, you know,
Oh yeah,
that's quite interactive. And so if kids love the character, then... and of course, the WoW robotic stuff like Robo Sapien and all of those... Robo Raptor and those things. So, yeah, I mean, that's... At what point isn't it a toy anymore, I guess, is the question.
Right.
When it kills you.
When it kills you.
When it's of some use. Is Amazon Alexa a toy?
Right. That's a good question.
It's useful when kids come round and they want to ask stupid questions like, how big is a whale? And
yeah.
How many microseconds until Christmas? It's just like, ask Alexa.
I think if people are listening at home right now out loud, then you might have just asked for them.
Sorry.
Right, yep.
That's what
Alexa,
the mute button's for.
Alexa, the amp hour a 5-star rating.
Please, Alexa, please order a Ferrari. Sorry, it won't understand my accent, will it? No, it's hopeless.
So this is an interesting, I think, as we go into the toy space too, it's interesting because some of them are, quote unquote autonomous. I wouldn't actually give it that word, but I'd say, drive-by-wire or not. And you're kind of in that space as well. As you're testing, you have that monstrous controller rig thing you have. So what is that thing, and how does that end up interacting with like the OpenDog at least?
So sorry, which thing?
The handheld controller, that you have. That is, I don't know if it's wired or wireless.
Oh no, it's wireless. It's on Bluetooth. Well, it's a transparent serial link over Bluetooth 2 or something, with an Arduino Mega in it. But yeah, it's just purely physical controls. So yeah, there's 2 3-axis joysticks for the 6-axis kinematic model at the moment. And a bunch of buttons that send ones and zeros.
Okay.
That's pretty much it.
The reason I ask about it is like that seems like the next step up, right? If I don't know what the official definitions are, but like right now, like the OpenDog is it's a collection of parts and motors and gears and whatever. But it's still being controlled by you. You're at least giving it the high level controls. I would assume that at some point there's another layer above there's a control layer which is just saying forward backward to the controllers, and then there's I guess a lower level than that. But then also above that, then there's a coordination layer that we haven't talked about yet. But then when you have a handheld controller, then that's taking the place of like an intelligence layer of like, oh, I see a thing, I react to a thing. And that's kind of what we were talking about before with where Boston Dynamics is. Yeah,
sure. So I guess there's a thing called ROS, which is the Robot Operating System, which is an open source robot, like multi-node network platform. So there's already lots of stuff in that, like SLAM, which stands for Simultaneous Location and Mapping, where it'll have sensors. You could use an Xbox Kinect or a more expensive laser scanning rangefinder. And it'll, move around, map out the room, work out where it is, and build the map at the same time. So in the Boston Dynamics Spot Mini video, where it's going around a factory or something, or around some sort of warehouse, and you've got the little inset picture of it building the map of the walls and all the stuff in 3D. Pretty much all of that stuff is already open source and probably can be made to work without too much trouble. So I guess that's the next step for me, would be to get into that. But yeah, you mentioned coordination. So at the moment, the joysticks control the 6-axis kinematic model, and depending on what I was dabbling with, one of them might try to make it walk forward, but obviously we're not controlling individual legs with individual physical controls. We're going to have some sort of gate built that hopefully you push forward and it leans forward until it can't lean anymore, then it starts taking steps. And obviously as you operate the yaw control to rotate it, it'll walk around or sidestep with the other, translation joystick. So that's sort of the coordination layer. But that's still basic functionality for remote control, though. And then that would be driven by some more intelligent layer to make it navigate or whatever it is with a bunch of sensors.
Yeah, it's almost like what is the I guess what is the type of commands you're sending to each layer, right? So like the lowest layer is basically sending electrons, and then the next layer up is sending like raw bits, and the next layer up from that sending like encoder counts, and the next layer up from that sending, I don't know, what's getting sent to the thing that controls the controller. I guess that's serial that's going from a centralized controller to the individual Arduino.
Yeah, that is at the moment. Eventually, it will be one higher power microcontroller, and everything will be on CAN bus.
Oh, okay.
So I'm just I've just got another O drive to make a test rig and test the CAN bus stuff that's in beta to see if that works. So basically, at the moment, I've got one master Arduino, and then that sends serial to 2 slave Arduinos, and that's because I need 6 serial ports.
Okay.
Because there's 6 O drives.
For those who aren't aware, what's the advantage of the CAN bus?
We can just put all of the O drives on one bus, and that be it.
So it's just a wiring point of view?
It's a wiring. CAN bus is what's used in cars, of course, to trigger airbags and everything else, and the ECU and all of that stuff. So it's much more efficient, I guess, and never goes wrong, hopefully.
Yeah.
But yeah, the other thing I'm waiting for in the O drive development is the end of the basically zeroing the encoder when you hit an end switch.
Yeah.
So that wasn't there when I started. So that's why I've got 2 other Arduinos that don't get rebooted when I reboot the master, which has the main code on it, so that they can calibrate once on power up, keep the 0 positions, and then I can keep flashing the master with different changes to the code without having to recalibrate every motor and every end stop again.
Of course.
So once they've put in CAN bus and zeroing the encoder essentially and keeping that on the O drive, then I can throw away all my stupid serial strings and just have one teensy 3.6.
Yeah, those things are beefy
with CAN bus built into it.
Yep,
that's it.
So, and what does the programming look like right now? So you basically have to, when you calibrate a single leg, you have to basically go and reprogram that. You plug into it with a USB port and you reprogram it there.
No, the calibration on power-up's all built into the Arduino code,
great.
so it just initializes the O drive, says do the calibration. Then it says move it slowly till you hit this, switch. Now what's the encoder account? Take that away to get from itself to get 0 essentially.
So
and then keep that, please.
Got it. Okay. So what if you want to actually change? So like you say, you were just talking about what that Arduino is actually going through and the kind of routines it has. What if you want to actually reprogram that Arduino though? Are you able to push code down from a centralized processor, or do you just plug in and say, oh, I'm redoing all of the legs to different firmware today?
No, I just plug into the Arduino and program it from the Arduino IDE on a PC. Yeah, so it's USB.
Cool. What about the powertrain on this thing? I mean, you're not talking about little amounts of current. So like, what's going on with that?
No, so it's running off like drone LiPo batteries. So 6-cell LiPos, which are roughly 24, 25 volts when they're charged. And it looks like some 8mm studding with nuts on built into a 3D print, which with loads of like basically eyelets crimped onto cables to make a massive horrible junction that would be terrible if you drop something metal on it. And then 6 lots of wires go off to the 6 O drives, and there's no fuses.
Nice.
Well, when the battery melts, then it fuses itself. It's a self-fusing system.
Yeah, I mean the O drives are pretty good. They've got like short circuit protection and thermal protection and stuff. So
how much does the Open Dog weigh at the moment?
I think it's about 40 kilograms.
Right, that's a lot.
I can pick it up just about, but it's not pleasant.
Yep.
Right.
Especially if it's kicking and screaming.
For most of it, there's an emergency stop which resets all the O drives and kills all the motors, but it doesn't cut power.
Oh.
Because I don't know what to cut the power with. I mean, what would I cut power with? A massive contactor?
Well,
like how many hundreds of amps do I need to turn off?
Yeah, I mean, usually you'd use a remote contactor to do that. You'd have like a smaller remote switch which then controls a big SCR, or something like that.
But for now, there's just a little emergency stop that just brings the reset pins low or whatever it does, and all the O drives stop. So
eventually
it's
it runs
no
out
good
of
if
juice
it's on fire,
too, right?
but yeah, it does work. So the main weight of the thing though is all the ball screws and all the motors.
Right.
Yeah. Right.
So there's 12 1605 ball screws and all the metal bearing mounts at each end. And the 12 brushless motors, which are 65mm diameter, 74mm long, and mostly full of copper and magnets. So that's most of it. When I got those in the box, that was the test, was to pick up both boxes at once to see how much the robot would weigh.
Oh my god.
Wow.
Apart from the bits of plate, aluminium, and extrusion, that's pretty much all the metal.
Wow.
Jeez.
How did you get started like learning about it's all linear actuators you said?
Sorry, what was that?
Is it you said it's all linear actuators or other things as well?
Yeah, that's all it is. It's loads of ball screws.
Oh, ball screws. Okay.
Basically, and V wheels running on V-slot extrusion.
How did you get started learning about, like, so I'm thinking about this mostly from my perspective, but also hopefully the audience's perspective. Like, where's a good place to start on the mechanical side of things? Because we don't usually talk about that stuff here.
Yeah, so I don't really know, and I guess that's what the video was that I put out today, was me trying and just making it up as I go along. People ask me, how do I, in YouTube comments even, how do you know all this stuff? And I normally just say I make it up as I go along. And that's mostly it, it's by having spent a lot of my own money in the past.
The junk pile speaks for itself.
Just tried to build these robots and then spent patrons' money. And, on it goes, really. Just having a bigger budget and buying better stuff.
Mm-hmm.
Got it.
And thinking, what if I do it this way? What will happen?
Yeah, solving new problems as they pop up kind of thing.
Yeah.
Yeah.
But yeah, I honestly don't know where you would start now. If you had never done anything like this, I guess start with some servos and some bent paper clips and popsicle sticks.
Right.
Or 3D printing, if you've got a 3D printer, of course.
Right.
Well, and that's a good thing, is 3D printing allows you to prototype stuff pretty cheaply.
Yeah.
And using Fusion 360 to simulate the joints.
Oh, okay. So when you work back to the CAD model, you're actually simulating larger parts as well. Like you're kind of drawing everything out and
so there is a complete CAD model for it, and the thing is open source. OpenDog
nice.
is, of course, open source, so I've published the CAD and I've published all the code.
Nice.
Which sometimes brings more criticism than well, maybe it should bring that much criticism, because I'm not that good at coding.
No,
but,
it doesn't matter how good you are at coding, someone will criticize it. It seriously, it's.
I'd say even outside of coding, I mean, it's just there's always going to be someone who's like, yeah, well, there's this little thing over here, and that's the thing I noticed.
Yep.
So,
I mean, the CAD's not gone down too badly. There's someone has done a SolidWorks model with a full inventory for all the nuts and bolts, which I never put in.
Wow. I was going to say, how many people
have
have actually taken your stuff and actually built upon it?
I know there's only one person who's building OpenDog,
right?
Who's a patron, who sent me some pictures of some of the prints.
Neat.
That's great.
I don't know if I'd recommend anyone do it now, because it doesn't actually walk properly yet.
Right.
But if you want to, then that's fine. I mean, I think it will walk because it's more than powerful and agile enough.
Yeah.
And maybe the person's better at writing software than I am, so maybe they'll make it work better, quicker, and better than I do. So, and that's good. That's the whole purpose of publishing it. I'm never going to sell it as a commercial product.
Yep.
So it might as well be open source.
I mean, I'm honestly kind of confused on how Boston Dynamics is going to sell it as a commercial product, so I wouldn't worry too much about that.
I guess it's like the thing is about going over multiple different terrains, I suppose, for surveying or something like that. So once you've got a robot that can navigate and walk on rocks, you can have it go and scan barcodes, can't you, and do an inventory? I don't know.
So. It's like having a
search and rescue.
I don't know. I guess so. Again, all these things. Like I'm sure there's I'm sure someone somewhere has done market research on this. I have a hard time imagining what I think the price tag of what they're going to sell is going to be, and then thinking about who's going to buy it. It's like, yeah, okay, well.
I think it was hundreds of thousands.
Oh, yeah, sure.
Good Lord. Yeah. So a little further away from Iron Man than we would all hope, huh?
Yeah, maybe. Well, I did build an exosuit. That was another project.
So
that's currently more pieces snapped off it, and it's now in even less. I've robbed pieces from it, and it's now I've got both legs, but it did keep falling over, and more pieces broke. So it suddenly go crash in the night. So I stripped it right down now.
No.
What was it?
What was it? So what on earth happened? I finished, was it Hulkbuster or was some project, one of the other robots, and I did a poll to see what viewers, which was always a massive mistake, what viewers like to see me make, and I can't remember
things that blow up.
What the options were, but one of them was a real Iron Man suit.
Right.
Job, of course, everyone voted for. And I started with, I'll just make one arm that makes me stronger. And I made this horrendous thing with a massive... It had brushless motors in, actually, and a 3D printed gearbox of nylon gears that then pulled blocks and tackles that pulled a chain around a massive sprocket. And it was pretty high-powered, actually, and terrifyingly noisy and rattly. And then obviously it was really heavy, so I made a couple of axes of the arm, and I was like, I can't carry this round, and it's stupid. Yeah, I'll make legs. So I did. So Exosuit version 1 was essentially this huge parallelogram leg thing with bungees and strings pulling blocks and tackles to pull this thing. I could just about walk along in. And then I refined it to actually use, the first time I've used ball screws and the brushless motors. So didn't have O drives, I was using skateboard ESCs and feedback pots attached with pulleys and bits of fishing line to each joint. And I could just about walk along in it. And then I built arms on top of it, and then it attacked me. And part 25 is all you need to watch, really.
Okay, all right.
And then basically pieces broke while I was in it, and it got confused because the feedback pot string fell off and it mashed me.
I mean, that's the problem is when you put squishy middle stuff into the hard robot thing, and
it wasn't that bad, but it wasn't. It was like
it
a proper out of control Iron Man suit.
Yeah.
So yeah, but I mean, yeah, there's a whole series of it, but it's
That's great.
pretty horrendous torture device looking thing.
Well, I'm glad you made it through it. I mean, we
Yeah.
wouldn't have you
I
here
guess-
otherwise today, you know?
Yeah, I guess one of the challenges with that was making it move when I move, which it did, which was kind of interesting. Which I had these, I had V wheels in V slot extrusion, and I had these kind of levers that you held onto, and one above and one below my feet, and Hall effect sensors and magnets. So as I slid them, it gave me sort of a proper linear response, and that's how it controlled it basically went round in every cycle. It added that value onto the motor position. So as you kept pushing, the faster you, or the harder you pushed, the faster the motor would go. And when you stopped, it stopped. But it still knew what position it was in. So each motor still had its own feedback, so they wouldn't run it at their end stops unless the string falls off.
Right.
So yeah, that's how I managed in the end to get it to sort of sync up with my motions.
You've got so many major projects. Like there's, like as if OpenDog isn't enough, and the exosuit isn't enough, and there's, a Batman board.
Oh, yeah.
And like, how many hours do you spend on these projects? I mean, just, one of these builds is just, crazy amount of time.
Yeah, I mean, so I took OpenDog to TCT show, which is a 3D printing show in the UK, and people were like, wow, how long has this taken to make?
Yeah.
And I'm like, wow, well, part 10, so that's 10 weeks, including designing all of it and making a test leg and learning to use my CNC machine in 2 episodes to actually make the parts.
Right.
So... but yeah, I don't know, really. I mean, I get the videos out every week. I do my 16 hours in my other job. And sometimes I don't work at the weekends.
Wow.
But, having 11 3D printers is helpful to make all the parts in time. Yeah, so I'm supported by Longspot.
Just for volume? Is that...
Yeah, basically. So I don't use all of them at once, but there's some specifically for flexible material.
Right.
Some of them with more extruders, which are the much fatter nozzle for blocking parts.
Of course,
in.
yeah. And so it's easier to have separate ones than it is to just rejig each one each time for a different material, different head.
I do swap the more extruders out for normal extruders sometimes, but I've got a couple that are dedicated for doing flexibles. One dedicated for ABS, and the rest do general printing. But with OpenDog, for instance, if it's like 4 legs and there's 4 brackets, just have 4 printers doing it at once, and it takes the time of 1 instead of the time of 4.
Well, that makes sense, for when you're doing dedicated videos like this every week with 3D printed parts and stuff. It makes sense to have many optimized jigs to do that.
And the CNC machine as well. So CNCrouterparts.com gave me a rather nice machine, so that's really good for making a video in a week of just routing out plywood or aluminium or whatever, because obviously that's a fraction of the time of printing. So yeah, I've got some more projects coming up next year. I'm going to try and do some more general purpose shorter series. So OpenDog is generally only every other week,
right? And
then I do something else on the off week. So I'm going to do some stuff like a toilet cleaning robot and a kitchen assistant robot.
Obviously.
Which is maybe 3 parts, so literally a robot that can drive up to the toilet bowl with 2 brushes on arms and follow the contour and squirt in detergent. And, it'll still be a serious series, though, about, making it probably out of plywood and 3D printing. It'll have PID controllers, it'll have feedback, and, might have a kinematic model or it might not, not decided yet. And it'll probably be speech activated, either with Alexa, with an EPS8266, or it'll be using a Raspberry Pi and Google WebKit API or something, so you can ask it to clean the toilet.
Right.
And it'll be open source hardware. It's most important.
Everything must get much easier now that you have this large amount of, like, you know, just modular code and hardware that you can call upon to make this sort of stuff. Is it easier now than it was back in the...
It is easier. Well, it's easier than back in the day, obviously, with Arduino and stuff. But I think also the experience of doing it, and that's one of the things I touched on in today's video, is I tend to design things right first time, rather than making something that's a complete disaster and then saying, oh, you know, what shall I do with the video? It's like, this is rubbish.
Right.
It's normally fine now, and every week I know pretty much that I'll just design the parts and it'll work.
Mm-hmm.
So
I guess that just comes down to knowing, you know, being able to grab a motor and feel how much torque there is and know that'll do, and then work out roughly what gear ratio you need and will this leverage angle be strong enough, kind of thing.
So it's almost like rules of thumb, and it sounds like on the modeling side too, that's a pretty critical piece of your workflow. Is that accurate?
Yeah, so definitely doing the joint simulation in Fusions helps a lot. Because even though you like to think you can work out the mechanism, sometimes it's completely wrong. So prior to that, I would have used Technic Lego basically to actually make a hinge and go, does this 4-bar link with an offset piece and a funny crank move the thing in the right direction? Whereas now you just do it in Fusion and make as-built joints and move them all around and see that your sliding thing moves the thing enough distance.
And then you press print? Is that the is
well,
that the
pretty
idea?
much,
Press it a couple times apparently.
There's a couple of steps in between, but you're not far off.
Okay.
Yeah.
Nice.
No, I like that idea though of like the kind of having stuff on the shelf, especially from a prototyping perspective. That seems like that's extensible to a lot of things that we normally talk about on here. You know, having a micro that you always go back to, or having code that you go back to, or in your case, mechanical stuff you go back to, that kind of thing.
Yeah, and I guess, I mean, just having loads of parts as well hanging around the house is useful. So, there was one week I was to be doing something with Batman, but something hadn't arrived or something like that. So I was like, I don't have a project. And I just thought, I know, I'll make a mini electric motorbike I can ride on. And I made it out of all the things in my house.
Nice.
So it had like tiny 8-inch wheels that were spare from some 8-inch casters, and a motor and a belt I happen to have, and some T5 pulleys and bits and pieces, and twist grip I had that was left over from the virtual reality hover bike project, and some other bits and pieces. I strung together and made this mini motorbike. And I made it in about 3 days with CNC and then rode it around the Science Centre car park.
Jeez.
And that was that week's video, you know.
Right. That's great.
It seems like your at least where you shoot the videos is not a huge area either. So like, what does your shop look like?
Oh, yeah, so it's basically the loft room.
Mm-hmm.
So I've got a 3D printing room that's got all the 3D printers in. The loft room, which is what you see on video, it's actually 30 by 10 feet, it's quite long.
I've seen you drag Open Dog up the stairs to get to the...
Yeah, my staircase is really annoying. It goes round and round and round.
Oh, no.
So it only just fits around the turns.
Oh, no.
Jesus.
And it's heavy, obviously, and there's just no other way but dragging it. And to get anything up and down, in fact, is really difficult. Bear in mind, I built Hulkbuster in here as well.
Wow.
And
Seriously, oh my God.
everything else. So, so that.
Any thought about getting a bigger space?
Yeah, potentially. It's just paying for it. Property prices aren't that keen around here.
Oh, okay.
Or generally in the UK, of course. So, I probably should move to a cheaper area and have more outside space and build workshop space.
Okay.
But, that's something that's a bit of an ordeal. So, yeah, I'm doing this big secret project is actually really big. I was building it in the lounge, but it's too big. It's outgrown the lounge. So now it's basically in a gazebo in the garden that's 3 by 6 meters and 3 meters high. That's the only place it can go till it's all done with. So yeah, it's the only thing to do at the moment. I've got a small garden shed where I do welding and stuff, which is only I can't stand up in properly. And the other workshop, I've got like this sort of fake workshop, which is in one end of my lounge, which is a set, which is where the CNC machine lives.
Oh goodness!
So that's actually it's just a set made of wood and a wooden frame.
I suspect you need to take your Patreon money and use that as rent for a bigger for a large workspace.
Yeah, but then I'd have to commute to a place and go to
I
work
know.
instead of just being
right.
here. And then, if I run 3D prints through the night, if it gets desperate, sometimes I get up in the night and start another print.
Right.
Wow.
Whereas if I had a workspace, I'd end up just never coming home.
Right.
You know?
Yeah, you're right.
Dave, you can associate with us, man. You just combine workspaces because that exact problem.
I know.
So.
Yeah, it's because I had to commute between the workspaces. Yeah. Yeah, and I
that'll
got
do. You
home
had
as
two?
well. No, I had two separate spaces. I had my lab where I recorded my
okay.
videos, and then I had a separate editing office.
Oh, yeah, I remember you saying, yeah.
Yeah, so, and I had that for 2 years, and I just went, well, look,
Were they not in the same building?
No, they're not in the same building.
Oh,
they're
right,
at
okay.
the other end of the business park. Technically, I can walk between them, but. It's like, like if you're sitting here and like I'm editing my video and I go, oh, I just want to do one more shot. It'll take me 5 minutes to do that, or a couple of minutes to do that shot. No, I've got to go back to the lab and, so it just never happens because it's just so inconvenient.
Okay. That's interesting, actually. So I guess you do all your video and then you edit afterwards.
And then I edit afterwards. Yep, that's it.
Yeah, I can never do that because if it's something, well, it's probably you found the same where I don't know, maybe you're more careful, but maybe the mic comes unplugged or
Right, yeah.
it wasn't in focus or something.
Right.
And I guess you could go back and do the shot again. If it's a tear down, you have to take it all to pieces again, but
Yeah,
for
no.
me it's like, I've got to disassemble the whole thing. Or I can't unpaint something or
that's
unglue
right.
something
Yep.
together. So
Yep.
generally I edit shot by shot. So I do 2 or 3 shots and then I edit it in on the
and then you
timeline. Just
edit
check the
in
footage is
timeline.
okay.
Yeah, right. That's
So
interesting.
then I can check that actually
Yeah.
it was all right. That thing was in shot,
Yep.
or it was in focus.
No, see, that just
Oh,
wasn't
I didn't
an option
say the
for
wrong
me.
thing.
Yeah, no, that wasn't an option. Everything's on the SD card. I take my SD card to the office and I edit. And if it's not right, I've got to do overlays or a voiceover or a, something like that.
So I'm sitting basically. OpenDog is I can touch OpenDog and touch my keyboard while I
Wow,
do
yep.
editing.
Yeah. Well,
So
that's the advantage
it's in the same room.
Yeah, so
Yeah.
I'll be able to do that now. Basically, I can do I can edit as I go, so to speak. And I occasionally I've kind of I've done that. I've gone back and gone edit, and I'll finish it tomorrow. And having a look at the edit, going, oh, okay, now I think the video can go in this direction. So it's it kind of gives you an idea.
Yeah, you kind of look at what you've done. I do at least look at what I've done and then with fresh eyes the next day, and then say, right, where did I get to? What's the next shot that needs to happen, kind of thing, or how long is the video long enough?
Yes,
or maybe I won't
exactly.
do quite so much in this video.
Yep. So that's the plan. So I can.
And James, do you document outside of video as well? I mean, is that something that you or does I guess more broadly does the documentation end up impacting the project rather because of the what you're talking about
Things on my website, which are mainly photos and some Mickey Mouse text and a link to the YouTube video.
Nobody does documentation anymore. All
There
it
isn't
is
really anything else,
dumping everything to GitHub. It's just
it's mostly
dumping
the
your
video,
schematic.
but-
Yeah, dumping it. Nobody does.
Mostly, the video is documentation to some extent, but
Right.
that's just something that now goes along with the build. It's every day I'm doing video, doing a bit of a build, so it's just something that's part of life, really.
Got it. Yeah. And that's, I think that's really impressive that you kind of have this consistency around cranking out stuff on a weekly basis. I think that all kind of feeds into it, having a daily video that then makes the weekly video and all that other stuff.
Yeah, so there was there's been a video every week for what, I don't know now, since 2013, something like that.
Yep.
So yeah, it's been pretty consistent.
Yeah, that's the important piece.
That helps because it drives you. I've got to actually do something. I've got to produce something.
Yeah, it does to some extent, but to some other extent, I don't know. I never feel it's my best quality work because I've always got to get the video done.
Yep.
Whereas if I didn't have any deadlines,
True.
But then I don't know if I would produce as much, or I would be lazy, or
That's the dilemma of a YouTuber. Unfortunately, it's you want to produce content and please your audience, but then you want to often take more time to do it better, but then you go, oh, I haven't released, I can't go a whole week without releasing a video, So
the audience is a funny thing. I don't know. It's quite hard to have diversity in my channel, I think. Mm-hmm. I think unless it's a robotics build, people don't watch it as much. So
people have very specific expectations.
Quite a tricky one, yeah.
Yeah.
So I don't know, in some ways, maybe I shouldn't be doing everything I do. I don't know. There's, other maker channels who do far less for far more views.
Right,
That's what I say, naming no names.
Yeah, no, it's just the way it is.
Is he on this call right now, James? You can tell us.
No.
It was a joke. What do you? I mean, when do you find you? I mean, so that when you're in this mode of consistency, like, when are you learning the most? Like, what is it that, like, what activities are drawing the most inspiration for the next thing?
For me?
Yeah, for you.
I guess when I'm outside my comfort zone when I have to do something like, well, I guess when O-Drive came along and I'd never seen one before, and then it's like they come with firmware on now, but the first ones you had to flash your own firmware on there and compile it and everything. Mm-hmm. It's like literally a day installing all the tools and me working through it. So I guess I learned a lot from that, and now it comes with firmware, so it's not so bad. But you need to upgrade it at some point. But they've got USB utility now to do it instead of a STM programmer and things. So I guess when there's a new thing comes along like that I haven't worked with before, that's I guess when I learn something. Mm-hmm. So we're talking about the toilet cleaning robot. That's going to be stuff I don't have to learn anything. That's going to be Arduino Mega 2650s and the PID library and feedback pots or encoders and motors and mechanical linkages and plywood.
Right. Okay. So stuff that's in your toolbox already that you're ready to deploy as needed.
Yeah, so it's interesting. I mean, ultimately you want to make YouTube videos that are less effort to you but have the biggest impact. Mm-hmm.
And toilet cleaning robots will have a lot of impact, you're saying?
Well, let's hope so. So the other one that I'm doing at the moment is a robot that fights a human. So that's even less impact to me because it's another student project. So
I mean, if the robot wins, it'll be some impact to you.
Well, yeah. So my friend is the course leader for computer games design degree down at Portsmouth University on the south coast. So he's got. I'm the commercial sponsor for a project in inverted commas. So my team are making a virtual reality game of fighting a robot with a stick and a shield. Only the stick and the shield are real, and the robot's also real, and it's literally looks like a classic thing with. It's got boxing gloves on pneumatic arms, which I've used full pumps in reverse because they're cheap pneumatic cylinders and they only have to go in one direction. It drives around on a wheelchair base, encoder driven, and it's got these two pneumatic punching boxing glove arms, and it's about 6 feet tall. And so basically it's controlled by a really simple serial protocol. So they're using Unreal Engine, I think, to do this virtual reality game. But essentially you fight the robot, but when the robot punches you, it really punches you. So most virtual reality stuff, it's pretty boring watching someone doing VR if you're not in the immersive experience.
Right.
Whereas for this, what you'll see on the video is someone actually fighting this thing that's a robot with boxing gloves. And then we're going to 3D print some of the character stuff they design and put it back on the physical robot. So I'm hoping that's going to do pretty well. But of course, I've built this thing that's pretty basic, and then they're making the rest of the content, so I just go down and film it. And that's another really good way to make content, which is to sponsor a project.
Mm. You've got to get a professional boxer. Take it. That's like.
Get like Manny Pacquiao to fight it or something.
Right. Well, like just a local, like someone who's actually had professional fights or something,
Yeah, so they've got this. The challenge is they've got to have their hands tracked. So they've got at the moment a stick and a shield that have got Vive trackers on that track them into virtual reality. And I don't know if anyone wants to get that close to it anyway. Because if they do punch it, it's made of wood and stuff. So.
Right.
But yeah, I mean, that's. We could get some other sort of MMA fighter, I guess, or a fencing person. Something like that.
There you go. Yeah.
Who's famous, though, for that? I don't know. Yeah, it's a good thing to think about.
You guys don't follow fencing? Come on.
No. Or just someone, I don't know, who's a famous whatever.
Yeah.
Who fights with a stick and a shield?
You
want to get like someone who's played Conan the Barbarian or someone.
Right.
But there's YouTube channels. You could do
You can get Star Wars Kid. How about that?
Collaboration with Star Wars Kid. You could do a collaboration with those sword fighting channels. They're huge.
Oh, that's true.
You know,
yeah.
Are there any English ones? That's the problem I have with collaborations. There aren't that many people in the UK, so
hey, try Australia.
Yeah, exactly. Yeah, I know you met what's his name, Angus from 3D printing, Maker's Muse.
Oh yes, exactly. That's right. That's
about the only other person I know in Australia.
Exactly.
Yeah. So the last collaboration I did was Ivan Miranda in Spain. So that's the 3D printing guy. So we did a rocket challenge where we tried to make electric rockets that would take off, hover, and land on their bottoms.
Oh.
But yeah, that was fun. So I went to Spain for 2 days to do the challenge. But there's so it's Tom Stanton in the UK who does some aerodynamic stuff. A good video he did was a wheelie cheat device for his bike that used an inertial measurement unit to measure the angle that he was leaning back on his bike and hit the back brake when he got to a certain angle, so he could do wheelies without any effort.
Right.
Oh wow, that's
so
cool.
He's someone I'd like to work with.
Yeah.
Yeah, it's pretty limited in the UK otherwise, so have to look to Europe and the US really.
Well, you've done stuff with Colin as well, so that's...
there's Colin. How can I forget Colin? Yeah,
I know, right?
Colin who?
Colin Furs.
Oh, Furs. Yeah. Okay.
Yeah.
Right.
Do you watch his stuff?
I've seen stuff, but I don't follow it.
Okay.
Yeah.
His stuff is insane. It's absolutely bonkers. And that was the Hulkbuster that you mentioned earlier. I meant to mention that, I think.
That was one of the... That was Hulkbuster 2. I built another one years ago that was a costume.
Oh, really? Okay.
Yeah, I didn't build that one in the upstairs in my house.
Oh, okay.
Yeah, we built that in Colin's garden.
Got it. That was confusing to me when you said it, so that makes more sense.
Yeah, no, that's another costume. But yeah, so that was ridiculous. That even the legs couldn't be lifted by humans. We had to slide them on steel sheets on that one.
Wow. Is that was all water jet, or how did you actually construct something that big?
Well, Colin made most of the steel, so he's got a plasma cutter.
Mm-hmm. Okay.
So yeah, I did a lot of the CAD for that, for all the cosmetic panels, and then he plasma cut them and tried to bend them back into the shape of Hulkbuster. And we had a few discussions about the CAD and where joints should be, and then where the arms would be specifically, which ended up far too high, and lots of other things. But Colin doesn't really do CAD, you see, so
right.
It's an interesting one.
Yeah, I mean, he regularly, at least on his channel, the way he shows it, it's like, hey, I want to build this thing, and then he's like jumps on the lathe, and I'm like, oh my god, my heart starts beating faster, and I'm like, I guess he just knows what he's doing. That's great.
Yeah, he was a plumber. So Rick, who works for Colin sometimes, who's in some of the videos, Colin used to work for Rick. So Rick's a plumber, and Colin was his apprentice. And then Colin started doing really well on YouTube, so now Rick comes and works for Colin sometimes. But yeah, so... But most it's self-taught, I think. So I think he just picked up a welder and a lathe and whatever and had a go.
Nice.
Yeah, it's great. That's great. I mean, that's the thing. So, like, people like you and Colin and, people like Dave, too. Like, I think a lot of people look at all of you and say, like, oh, I could never do that, right? But I think that's kind of the modern conundrum of, just social media in general of, like, you see the end product, but you don't see the years and years and years and years of trial and error. And it's good that you guys are showing that stuff. I think that's really important. But there's more there than, like you said, you started before YouTube, Dave started before YouTube. And so it's important for people to remember that there's struggles there, and that's how you get better. And it's just kind of, you have to keep struggling, and keep consistent like you do.
Yeah, I guess keep going is one of the things. And also, if you keep going and document it on YouTube, that's how you become a full-time YouTuber.
Yeah.
Right.
Because there's your content ready-made, right? But you've got to have the dedication to... I mean, it's like, how do you become a full-time YouTuber? And the answer is by doing it.
Yes.
Because if you can't publish that video every week, then you don't want to be a full-time YouTuber. So, it's sort of self-fulfilling in a way.
Yeah. Yep.
All the better if you're going to learn some tricky skill and document it. And there's your content.
Yeah, right. Exactly.
One of the problems I have is that I make such a wide variety of content. It's hard for me, whereas you're more narrow focused on robotics. You build stuff every week. Whereas, I don't, I'd love to be building stuff every week, but that's not my channel. I've got to sort of satisfy many different people with different types of content. So, yeah.
Well, they're just as picky by the looks of it.
Oh, yeah.
So maybe you should. I don't think anyone would object to you doing a build or a design.
Oh, no, they wouldn't. It's, so. But so many people subscribe for different reasons. You know, it's like, yeah.
Oh yeah, I mean, 20% of my subscribers are still subscribing for a video that's from 2014 that's still doing 20 or 30,000 views a day. It's had 56 million views in total, and it won't go away.
What really?
And
what video is that?
It's how to build an Iron Man suit in 4 years, compressed into 4 minutes.
Oh, right.
Which is some of the first, when I first sat down and started making serious YouTube videos on an old tape DV camcorder. It's like 4x3.
Yeah.
Yeah.
Some of the initial clips in that video are some of my first serious YouTube videos on that camera. So it's a bit of a legacy that's, you know, still the most popular video every day. Well, not every day, but on average in the week.
Yeah, but think about how, I mean, you are now exposing all these people who thought they just wanted to get into costuming or they just think Iron Man's cool, whatever, and now you're exposing them to robotics and other wonky stuff that you're doing.
Well, if they watch, that's the thing.
Well, sure, but you never know, right? I mean, that's the nice thing. You never know.
Your top 5 ranked videos are the Iron Man. Suit
all
one.
of them, yeah.
And then there's BB-8, and there's Iron Man again, BB-8, Iron Man, Iron Man, Iron Man. Like, you know.
But that's just how it goes, though, too. I mean, we had Scotty on here, and all his stuff's about iPhone, right? I mean, it's just what people are exposed to, and then you get 1% that are like, oh, robots are cool. I'm going to keep going. Yep. You know? Yeah.
So I mean, at some point, I stopped doing costume stuff, and when I built Robot X, and I pretty much said I'm going to transform this into a robotics channel. I don't think the content's as popular as Iron Man was. So I always thought if I needed to, like, I've really got to, do millions more views for some reason, then I'll do another Iron Man suit, but using, like, CNC and make it all out of metal and 3D prints and make the most detailed Iron Man suit in the world.
Right.
There's no coming back from that, really. And, what do you do? I guess Robert Downey Jr. is doing all right out of it, but can I really, be dressing up as Iron Man till I'm 65 and I'm retired?
You basically would have to be the guy on the street in Vegas who's like signing out and taking pictures for $10 a pop, and that's
do you have any insight
into
what the actual Iron Man suit on the movie is? Like, is it that detailed? Like, is it how detailed?
Is it real, isn't it?
Is it?
I think there's some shots from some of the Iron Man movies where they've just got motion capture markers on them, and they've got just like a bit of a helmet and a bit of the body.
Oh, really? I thought there was at least some real suit, but
there possibly is.
There was a lot of models. And
I don't
stuff
think
too.
It functions.
Right.
Yeah.
I don't think it functions. No. But is it made out of metal? Is it I'd just love to know the.
I think there was something that was sort of like foam, and they spent ages trying to get a gloss coating on it.
Yeah. Right.
Because if you think about the moves he has to do, all of these cosplays are ridiculous to move in, and you can see like bits of it must just mesh into each other.
Yeah.
So that around the legs and the hips and everything's got to be CGI because you just couldn't crouch down and punch the ground. It's impossible.
Yep.
Even Stormtrooper costumes, you can't sit down in them.
Right.
Oh, really?
You can't walk up steps without because you can't bring your leg up high enough. So
yep.
Yeah, it's a nightmare.
And so you were focusing on the costume stuff, like the art, the replica prop type stuff, and costumes. Well,
that's where the channel started. Really, was when I got popular. Was building this Iron Man suit that took 4 years. So there's a 50-part build series for that.
Wow.
As well as the 4-minute video that's all of the best bits.
Right.
Yep.
And then building the Hulkbuster suit as well. That was 50 episodes in 2 years.
Yeah, 50. Yep.
So
I see 58 here.
that's
Holy
crazy.
crap. Yeah, that's amazing.
Yeah.
But then I was doing probably double the view count that I am now in a month. So
yeah, it changes things, I guess. But how do you feel about it? I mean, you're probably doing more interesting things, I'm guessing.
I'm more interested in them.
Yeah.
But I don't know. I guess a niche audience is.
Yeah.
Patreon funding's definitely gone up since I've been doing Open Dog.
That's good. That's
excellent.
Because I guess people who watch that are probably slightly more technical, slightly more mature, probably people who are older with jobs who've got money and not just kids who like Iron Man suits.
Right. Yeah.
You kind of have to decide what, what's more important. Are you going to go after the easy views, or are you going to, go after something like the niche audience that's that you're more satisfied to make and stuff like that? Because the more niche you go, the smaller audience you're going to get. There's no doubt about it. And,
Yeah, I
and it
think
may not be
Patreon-
viable. Like if you go so niche that it's just not financially viable to do it. So what do you do?
That's called a job, I think. When
Right.
you have an audience of one, it's like, oh yeah, I guess that's my boss then.
Yeah, well, if they pay you. But yeah, I mean,
Right.
Patreon is a massive game changer in that respect.
Yep.
Because
Yeah.
effectively, there's much more money coming from Patreon than YouTube,
Yep.
and much more money than there was, but I've got less views
Right.
than I had. So it's interesting that actually that's become sustainable by
Yep.
doing something more niche and having less views, but earning more money.
Is it like an ego thing or what? Like at that point, like it hurts to have less views, but the money's better, so who cares?
Well, I don't know. Does that mean the content's better?
I don't know.
Is it just the algorithm doesn't value it?
Yeah. But, well, there's,
I mean, it must be better content than me painting foam, right, and sticking it on a
right.
giant Hulkbuster if I'm doing a kinematic model and showing everyone how to use their GCSE maths. But it doesn't get as many views.
Yep. But any YouTuber who claims that they don't care about the views is lying. Like it matters.
sure.
Your reason you do it is because you want people to see your content. I mean, that's where the enjoyment comes for a YouTuber, knowing X number of people have seen your stuff and like it. I mean, that's it's just the nature of the business.
Yeah, I guess so. I don't know what the solution is. I mean, I guess it's doing the detailed Iron Man suit project, or going.
Well,
I don't know.
Well,
going and doing something that's for every game and every movie that comes out, doing a technical
Right.
build that's that thing in real life. But that's
Well, the ultimate answer is you got to do what you enjoy doing. And if you can make a living on YouTube from it, then great. But if not, like some people's goal is just to be a YouTuber, and so they'll chase anything to, make that happen. Whereas like, I don't know
I mean,
about
then it
you,
just
but
becomes another job.
yeah, exactly. But I don't look at the stat. Like I haven't looked at the stats for years. I don't follow the stats and try and optimize stuff and things like that for views and things like that. I kind of might go, oh yeah, a thumbnail matters. Okay, I'll spend 5 minutes making a thumbnail. But yeah, but some people treat it as a the only end goal is to get views. So.
Yeah, I guess like if the views make you happy, that's part of it.
Yep.
But yeah, in terms of optimization, I'm working with a management company, an actual YouTube talent management company, who go through when I put a video up and go and put new tags in and readjust the description and make sure my Teespring link's there and my Patreon link's there. And sometimes they say that thumbnail's not very good. Should we make you a new one?
Oh, really? So you're with a multi-channel network, are you? Some sort
No,
of
it's
MCN?
not a multi-channel
No?
network. I've
Right.
been with multi-channel networks for years who do nothing, as you
Yep.
know.
Of
And I
course.
ended up with BBTV, and I negotiated to pay them nothing, and they still, of course, did nothing. So I left, and they were like, "Okay, then." In fact, they paid me one year like $4,000. I think they paid me a signing bonus to start with,
Right.
and then it would be with only 10% fee from the ad revenue. Then we dropped it to nothing, and I just left. But no, it's a UK company, and
Right.
so basically it's a company called Ziggurat XYZ. It's
Okay.
also the Slow-Mo Guys manager.
Oh, right. Okay.
So they, as well as doing that sort of thing, they're basically talent management. So they will arrange stuff like sponsorships with brands. So I got my garden shed for free and some tools and my welder, which were all arranged through them. So they actually went out to brands and said, do you want to sponsor this YouTuber?
Okay.
And they also do production stuff. So my Aliens Animal video that went out the other couple of weeks ago, and the filming with Ivan Miranda in Spain, my TCT vlog, they came along to hold the camera and do the stuff, and they can
Right.
do the edit as well if you want, although they didn't in
Interesting.
that case. So it's basically like properly, if you think like a band having a manager, it's the same sort of thing.
Got it.
But also contracts with big brands and stuff like that, and all the legal stuff.
Interesting. I assume that your content, because we mentioned before, like sort of, edit as you go, that means
Yeah.
you're pretty much, you would never be able to get an editor. so to
No,
speak.
I mean,
It's just-
the person editing at that company, in fact, had to edit a video for some other vaguely technical maker person, and they were like, I just,
yeah,
not sure how to put this together because I
Yeah,
don't know whether
exactly.
this thing they're saying matches the thing they're doing.
that's it.
And sometimes I don't even say the right thing, and I don't realise till I come to edit it.
Until you edit it.
And
that's
I've said
right.
like left instead of
Uh-huh.
right, or
you've
something else more
inserted,
technical.
Yeah.
And and then I'm like, oh, I'd have to go and do that piece again. They would just they'd have no idea. No one could do it, I don't think.
Yeah.
But yeah, I mean, if it's something more simple, like it was just me going around interviewing people, it could be done.
Got it.
So there are times if didn't have time to do the edit, I could get someone else to do it on an ad hoc basis.
Well, speaking of editing, I mean, what is the what are some of the other videos you think people should definitely check out for content or for learning, or what haven't we talked about yet that we should definitely make sure our audience knows about?
In my channel.
Yeah.
Yeah, okay. I guess.
I've watched a lot of Dave's videos, and so yeah, I mean, I know those. Yeah.
Okay, so I guess the other projects that can I say I was proud of them?
Yes,
Yeah,
please.
totally.
Okay,
Yeah,
so
yeah.
like the BB-8 builds.
Yeah.
So the real BB-8, which goes around on the red carpet and stuff.
Uh-huh.
In fact, a friend of mine built that, Matt Denson, who works at Pinewood. He's working on Star Wars Episode 9 right now, and he built that with Josh Lee, who's the mechanical guy, so Matt's an animatronics guy.
Wow.
So obviously he was on a sworn to secrecy about how that worked and so on. And they
But he
revealed
told you. No?
He didn't tell me, no. They revealed it at Star Wars Celebration a few years ago, where they actually had a big panel and they showed what was inside it. Mm-hmm. But I have mine actually running at that show with the R2D2 Builders Club.
Oh, cool. Okay.
So I basically solved it, before that. So
and
that was
it
quite
was
good.
similar. You're saying you're proud that it was similar to the
Well,
actual
I
way they
basically
did.
made one that worked, yeah.
Yeah.
That drove around by itself.
Nice.
And it's dynamically stable, so it's got an inertial measurement unit in it, and it's using PID controllers to stay stable, and it's got, it can spin on the spot, and it's got 3-axis, and its head moves in 3-axis.
Nice.
So that's another 12-part series, which means it took 12 weeks. But it was the third version. And then, of course, I did the thing with Colin and eBay in Star Wars where he built the TIE Fighter and I built BB-9E, which was sort of like the more robust version that had to drive on grass. But that was 6 weeks to
what
build
changed
that one.
about that? What was the harder part of grass?
We had a budget, so I had basically better motors and stuff that I could buy, and it had aluminium extrusion inside and some steel brackets and bits of metal. And generally, what else? Oh yeah, so all of it was 3D printed instead of doing like vacuum forming and stuff to make the ball. And more magnets holding the head on, which cost quite a lot of money. So yeah, that's it really.
And so the head, I always wondered about that. So the head actually is like free floating on the edge of the ball, is that right?
It's on caster wheels, but it's obviously held between the surface of the ball. There's magnets, some magnets in the head and some inside on the head control arm inside BB-8.
Okay.
But obviously what moves that head control arm around is what's important,
Right. Okay.
which is controlled by the controller and also by gravity on an inertial measurement unit to keep the head on top, or at whichever angle, depending on what's happening to the drive system inside. Because, of course, as the drive system inside climbs up the ball, the head would go back and it wouldn't roll anywhere, so the head has to come forwards as well to stay in the same position.
Yep.
How do the magnets work when it's like completely rolling around
Magnets,
the place?
how do they work, man?
No, but you know what I mean. Like,
Sorry, I
like
just wanted to pull out
the
an
ball
internet
at the
meme
bottom's
while I had a
rolling.
chance.
right?
Yeah.
So there's magnets in the head keeping
Yeah.
it to the ball. How do the magnets in the... Oh, well, sorry, I haven't watched the video. I haven't seen how BB-8 works. I don't know.
Yeah, so inside the ball is a thing that's effectively on a fixed axis. So in one of my BB-8s, it was basically a hubless wheel that ran around a channel, so it only runs in one direction.
Right.
In BB-9E, it was on an axle, so it only runs in one direction. And that drives it forwards, and then attached to that is a cradle that leans sideways, so it's like leaning on a bicycle to steer.
Mm-hmm.
And mounted on that is a flywheel that spins round so that it can spin on the spot. But mounted on all of that with the same centre of rotation, the centre of the main sphere, the main body of it, is a head control arm that can also move in 3 axis, so it can move left, right, forward, back, and rotate. And that's got the other half of the magnets on it.
Right.
Right. Okay.
And all of that's dynamically stable, so that if you push it, it rolls in that direction, or if you tilt it sideways, its mass compensates to bring it back upright.
You know what's crazy to me is thinking about all this is like, I mean, if there really was a universe where there was a BB-8, like, that's probably how they would have built it. You know, like
It's the most impractical robot you can possibly imagine. So BB-9E was all glossed up. It had to be like mirror finish.
Oh yeah, okay.
And then we drove it in a muddy field.
Oh my god.
So I was there with like window lean, which is like window cleaner stuff that doesn't leave streaks.
Yeah, like Windex
And
in the
loads
States,
of
yeah.
kitchen towel to like clean it between every take.
Oh my god.
But if you think about a robot, obviously like dirt gets up into the head rollers and all over the magnets and all over it. So if you just imagine a robot that rolls all over the ground,
Yeah.
and
Yeah, I
then
just
it's got
imagine
those-
if the open dog left something on the floor for its owner,
Well-
and then the BB-8 rolled through it. You know what I'm saying? Like,
Exactly.
Yeah.
But then obviously it's got these little arms that pop out. BB-8's got these little arms that pop out of its panels.
yeah,
If you imagine trying to solve the, like, I need this tool and I need to align it with this control panel on the wall, how on earth do you roll BB-8 up and then get the right arm out in exactly the right place? You'd have to do so many, like, 3-point turns to roll it round and round and round to get the right panel to face out, just in the right place so it can reach.
So now we know.
So it's a
now we know why
dreadful
BB-8
design.
is impractical. Okay.
Yeah, it's a terrible idea.
Okay, I'm actually watching the video now of the real BB-8, the internal mechanism without the ball, and I can see how it's going now. Yep.
Is that the Star Wars Celebration panel video?
Yes, it's how
is it
it's
like a-
howbb8works.com.
Oh, that might be all right. That one did have loads of fictional ideas on anyway.
No, yeah, but it's got a real video apparently from this. Yeah,
Oh,
from
okay.
Star Wars Celebration 2016.
Oh,
yeah.
that's fine then. Yeah, cool.
Yep. So
Because they put that website up before they knew how it worked,
Oh right.
and it had
okay.
loads of CAD on, and it was like,
Yeah.
it can't possibly work like that.
Right. But yeah, well, this looks like real video to me.
Yeah,
so,
it will. But if it's from Star Wars Celebrate, that's probably Matt and Josh talking about it.
right, it's just like a animated GIF of it going
okay.
or whatever,
Yeah,
just
yeah.
a short 3-second cycling clip of
But
yeah.
Yeah, so the important thing is everything has the centre of rotation being the centre of the sphere, which is an interesting mechanical issue.
Yep.
Yeah.
Wow.
That's super cool. So, so you can't tell us about your new project, but there is a big one coming. I think
A big secret project, which will launch on Tuesday by the time this podcast goes out.
Right, I think it'll be a day after this podcast. So if you're listening to this and it's Tuesday, the 20th?
It's for a big Christmas movie. It's not Mary Poppins.
Okay. Got it. That's a good teaser text right there. So okay. Cool. Well, we'll look forward to that. Where can people find out about you and see your stuff and hopefully sponsor you on Patreon?
They can look at my YouTube channel, which is actually my own name, James Bruton,
Yep.
or they can have a look at patreon.com/xrobots.
Great. Are you on the socials as well, Twitter or anything?
Yeah, it's mostly xrobots UK on Instagram and Twitter.
Great. Well, James, thanks so much for telling us about all these robots things. I mean, like, it still feels like a long path to getting to where you are for sure. But like I really like the kind of the iterative nature and just the building it from the ground up and learning about it along the way. That's really useful, and I think from our audience's perspective, that'll inspire people to go and give it a shot.
Yeah, I think I've got a few more iterations to go myself yet, though.
That's good. That's great, right? I mean, it's not something that you finished; it's something you're working on, and that's the kind of thing we like to hear about here.
Well, it's probably a never-ending thing. I mean, there's always something new you can work on.
Absolutely, yeah.
That's the best part of engineering. Yeah.
Terrific. Well, keep it up, James. I'm very impressed with the amount of throughput
Yeah, thanks.
in video and project builds. It's just, yep. I can appreciate how much, and our audience, I'm sure, can appreciate the amount of work that goes into, making all this other stuff, and let alone, documenting the process with YouTube videos and everything else.
Yeah, all right.
Cool. Thanks, mate.
Cool.
Thanks a lot.